Dart School presents quadrilaterals. At the very basic level, a quadrilateral is a polygon with 4 sides and 4 angles. Let me just draw a few quadrilaterals. All these shapes qualify as quadrilaterals. In a quadrilateral, there are 2 pairs of opposite sides. So this is one pair of opposite side, and this is the other pair. We have 2 pairs of opposite angles. This is one pair of opposite angles, and this is the other pair of opposite angles. So this one's opposite sides. Opposite angles. They are all present in one single quadrilateral. I'm just using the pictures to show you one for the opposite sides, one for the opposite angles, and so on. Our quadrilateral has 2 pairs of adjacent sides. Adjacent sides. Let me show you what that means. Adjacent sides are sides that lie next to each other. So these 2 qualify as adjacent sides, and so does these 2. Also, we could say this and this is a pair of adjacent sides, as well as this and this is another pair of adjacent sides. So the adjacent sides meet at a point, and then you have the adjacent angles. This angle and this angle are adjacent angles, and so are this and this. And let's not forget, this angle and this angle also form a pair of adjacent angles, and so do this and this. Just like the sides, the opposite angles lie opposite, but the adjacent angles lie next to each other, just like the adjacent sides. There are a few special types of quadrilaterals you want to know about. The first one on the list is a parallelogram. In a parallelogram, the opposite sides are equal and parallel, which means this side is the same length as this side, and they are parallel, and this side is the same length as this side, and they are parallel to each other. This is what you call a parallelogram. Also, the opposite angles are equal, which means this angle out here is the same measure as this angle, and this angle out here is the same measure as this angle. The adjacent angles are supplementary. So if you pick up any pair of adjacent angles, let's say this and this, they add up to 180 degrees. And it's the same for this and this. They're also adjacent angles, so they also add up to 180 degrees. And this plus this, and this plus this. So if you pick up any pair of adjacent angles, they would add up to 180 degrees, which means they're supplementary. Supplementary angles, 2 angles are supplementary when they add up to 180 degrees. Each diagonal bisects the parallelogram. I'm sure you know what the diagonal of a parallelogram or of a quadrilateral is. It's the straight line that joins the opposite vertices. So you have one diagonal over here and the other one over here. Now it says that each diagonal bisects the parallelogram. Bisects means cuts into 2 equal pieces or 2 equal halves. If you look at one diagonal, it cuts the parallelogram into 2 triangles, and the 2 triangles are congruent. And also the diagonals bisect each other, means if I draw the other diagonal, this length out here from here to here is the same as from here to here. It's been bisected by the other diagonal. And same with the other diagonal, this length from here to here is equal to this length from here to here. So the diagonals bisect each other, or they cut each other into two equal halves. A rectangle is a parallelogram, so it has got all the properties of a parallelogram plus a couple others. Each angle is a right angle and diagonals are equal in length. So if I can go back to the properties of a parallelogram, a rectangle is all of this. Everything about a parallelogram is true for a rectangle, and in addition, each one of the angles is a right angle and the diagonals are equal in length. Let me go ahead and draw a rectangle for you. This is how a typical rectangle looks. So as you can see, the opposite sides are equal in length and obviously they are parallel. From the picture it's pretty obvious. And then each of the corners have a right angle in them. Opposite angles are equal. Yes, of course. And they are supplementary because 90 and 90 add up to 180. That's perfect. And in addition to what you have for a parallelogram, the diagonals are also the same length. A rhombus is a parallelogram plus something else. So once again, a rhombus is a parallelogram with some extra properties. All sides on a rhombus are equal in length. So it can look something like this. All four sides are equal in length, and of course the opposite sides are equal in length. If all four are equal, the opposite sides obviously are equal. So they're all equal in length for a rhombus. And in addition to that, the diagonals intersect at right angles. If you draw the two diagonals, this one and this one, they form a 90 degrees over here. And all four angles are 90 degrees each. A square is a parallelogram plus a few more things. Probably you already know how a square looks like. All the sides are equal in length. So this and this and this and this, they're all the same length. Each angle is a right angle. So this is a right angle over here. And so is this. So is this. And this one. Diagonals are equal in length. So this length is exactly the same as this length. Looks pretty obvious, doesn't it? And also the diagonals intersect at right angles. And of course the diagonals bisect each other. That's a property of parallelogram. So the diagonals intersect at right angles. All these four angles are 90 degrees apiece. A square is also a rectangle. Yes, it is. In fact, it's a special type of a rectangle in which not just the opposite sides are equal in length, but all four sides are equal in length. And a square is also a rhombus because in a rhombus, all four sides are equal in length. It's a special type of a rhombus in which all four angles are equal to 90 degrees. So let's keep in mind a square is also a rectangle. It's a special type of a rectangle. Yes, it's a parallelogram. The rectangle is also a parallelogram. A rhombus is also a parallelogram, and a square also qualifies as a rhombus, a special type of a rhombus in which the angles are 90 degrees each. And finally, there's a special type of a quadrilateral called a trapezium or a trapezoid that is not a parallelogram for a change. A trapezium is not a parallelogram because only one pair of opposite sides are parallel, which means I have this side, I have this side. They can be parallel, but the other sides, the two other sides, this one and this one, they are not parallel. Therefore, this is not a parallelogram. Typically, you can find the roof of a house looking like a trapezoid. And when the non-parallel sides are equal in length in a trapezoid, which means the trapezoid can look something like this. Even though these two sides are non-parallel, they are equal in length. This length is equal to this length. What we have is an isosceles trapezoid or isosceles trapezium. That concludes our discussion on quadrilaterals.